All right, the final session of the day. This is the Technology Development and Demonstration session. And our session chair is Willie Williams of NASA. Willie is the Research Portfolio Manager in the NASA Research Office. And when I was talking with him late last night, he was telling me, oh yeah, I manage a lot of these programs here. This is going to be fun. So session chairs, watch out. We do have 6 presentations. We play all of them in series. We play the 5-minute executive summary that you can find in your agenda, online agenda, on the online program. And I do encourage you to go and look at the full briefings on those that you find interesting, also in the online program. So we'll have these 6 played one after the other. And as those go by, do not lose time. Do not wait. Go into your Q&A tool, which is at the bottom of your screen there. Click Q&A. Type who you want to answer the question and what the question is, and then hit the submit button. A couple of people forget to hit submit. They just hit return. Scroll down and hit the submit button, and we'll be able to see it. Do not put your Q&A, do not put your questions into the chat function, because we sometimes don't see that because the chat gets very busy sometimes, and we really want to address your questions. So to go to the Q&A as soon as you have a question and type it in. See if you can be in the first 10 questions. That'd be great. So now we're ready to go up and play our 6 presentations. Go ahead and play the slides.
Thank you very much for attending our presentation on next generation water recovery for sustainable closed loop living. This is a work being done by Faraday Technology in collaboration with the University of Puerto Rico. Faraday is a small business located just outside of Dayton, Ohio, where we do electrochemical engineering and development. This work was funded by a NASA SBR Phase 2 contract. Santosh Vijapur is the PI on this work, and we'll be discussing the rest of our collaboration.
In order for deep manned space missions to be possible, solutions and innovations are needed, which can reduce or eliminate the ground support. The water recovery system within the environmental control and life support system typically recovers about 85% with reduced process performance decrease, efficiency decrease due to incoming process contaminants. So there is a need to increase the efficiency or durability of this water recovery system. The technological approach behind this bioelectrochemical wastewater treatment is shown in this flow diagram. So basically the urea, which is a major constituent of urine, can be catalyzed to generate ammonia in a bioreactor. The ammonia, effluent ammonia from the bioreactor can be treated in an ammonia reactor, thereby oxidizing the ammonia to generate hydrogen, nitrogen, and thereby generating or creating clean water in the process. So talking about the urea bioreactor work being done at UPR by Professor Cabrera, they have utilized a microorganism called as Proteus vulgaris bacteria. It's a gram-negative bacteria, the SEM image of which is shown in the slide. So basically it can catalyze urea to generate ammonia. And the cyclic voltammogram picture on the slide on the far right shows the CV curves of the CV curves with and without urea. So when there is no urea in the electrolyte, you don't see any ammonia oxidation peak. Whereas in presence of urea, the Proteus vulgaris bacteria catalyzes the urea to ammonia, which is demonstrated by the ammonia oxidation peak in the CV curve. Faraday Technology is working on to develop ammonia reactor for ammonia oxidation. So Faraday has developed a technique to catalyze titanium foams, which is a durable support for ammonia oxidation. And we have used a typical fuel cell electrolyzer kind of reactor, wherein we are flowing the effluent electrolyte coming out of bioreactor through this ammonia reactor in a flow-through fashion as shown in the exploded schematic. Throughout this research program, we have optimized different process conditions and identified conditions or down-selected conditions that can give a complete or that can do a complete ammonia conversion. Here in this slide, the details of which can be found in the full presentation. In this present slide here, we have tried to estimate scale up of this proposed technology to the desired 6 liter per day of wastewater treatment. So down selecting the optimized conditions, we conducted trials using 1 liter of synthetic urine electrolyte, and used with our current footprint, reactor footprint of 2.5 by 2.5 by 2 inches, we were able to convert ammonia from 10,000 ppm to basically negligible ammonia detection on the ammonia ISE. And in order to convert or treat the wastewater to the 6 liter per day estimate, we would need a reactor footprint of 30 by 30 by 24 inches. And by doing so, we would be able to do a complete conversion of ammonia. More detail of the process optimization of the bioreactor and ammonia reactor can be found in the full presentation. So basically, we have demonstrated Proteus vulgaris bacteria to convert urea to ammonia, and the ammonia reactor to oxidize the ammonia to generate clean water. In zero gravity space flight.
Welcome everyone to a presentation about the NASA Hunch program. Hunch stands for High School Students United with NASA to Create Hardware. But as this presentation will show you, we involve a lot more projects besides hardware. How exciting it is to have students while still in high school design and fabricate valued products for the International Space Station and beyond. Since 2003, the NASA Hunch program has partnered with students by challenging them to make critically valued products for NASA. Each year, the quality, quantity, and diversity of these products has improved and expanded, as well as the number and diversity of the students involved in the program. Today, over 2,500 students in middle school, high schools, and some post-secondary schools participate in the NASA Hunch program. The NASA Hunch program is a win-win situation for both NASA, the students, teachers, schools, businesses, and the nation. Students benefit by practicing skills that are vital for the 21st century workforce, such as resiliency, teamwork, and innovative thinking. Schools benefit by implementing a that demonstrates that students are capable of the highest expectations. Businesses benefit by having a source of workers that are ready to meet the challenges that their company needs to succeed. The nation benefits by leading the world in technology.
To all interested in learning more about the NASA Hunch program, this presentation will tell you about the different NASA Hunch projects and how to join the program. The Hunch program has 6 different project types that are as follows. Hardware manufacturing, where students are machining and measuring metal products for flight hardware. Soft goods, cloth and flexible materials sewn by students, some for flight, some for training. design and prototype engineering projects, where students design and build prototypes of their ideas to solve NASA problems. Design Development for Flight program, where students work to turn the student prototypes into flight hardware. Culinary Challenge, where students compete to send their recipes to the ISS. Video Challenge, where students compete to make inspirational videos for NASA.
After reading this statement, which I wrote a couple years ago, it still holds true today now more than ever. With the expansion of the Hunch program, students in communities that aren't considered quote-unquote space states can be exposed to not only the exciting things that NASA is doing, but also exposed to new skills they might not get elsewhere in their education. Speaking from my experience of over 8 years involved with Hunch, including as a student and as a volunteer mentor, Hunch has led me to learn and become skilled in things like soldering, coding, electrical work, and machining, along with soft skills like public speaking and teamwork. These are all things that were imperative in helping me gain opportunities and have led me to the career I am in today as a systems engineer for spacecraft. Growing up in small town Montana, I never thought my career could lead to such an amazing journey in the space industry, and Hunch is to thank for opening my eyes to such possibilities.
Hello, I'm Mark Shumbera, Director of Business Development for AlphaSpace. I would like to thank the organizers of the ISSR&D conference for this opportunity to introduce a major upgrade to the MISSE orbital testing platform. We have significantly enhanced MISSE capabilities and have made it easier for customers to use MISSE for orbital testing. The upgraded avionics that we will be installing during our next mission early next year enable fantastic new capabilities like high-speed wireless communications and adds resiliency and significant flexibility to MISSE operations to support our customers' experiment needs. First, a little background. AlphaSpace owns and operates MISSE under NASA and ISS National Lab agreements. We are an ISS National Lab implementation partner and a commercialization partner. MISSE was the first woman-owned facility in space and is one of the most highly utilized commercial facilities on the space station. It was installed on the ISS in April 2018, and in a little over 2 years, there have been 5 missions that have provided on-orbit testing services for 780 experiments. Virtually any organization can utilize MISSE: NASA, other federal agencies, universities, nonprofits, and of course commercial companies. We also recently successfully renewed our AS9100 quality certification for the first time. Our next mission, MISSE 14, will launch in February 2021 with 4 experiment carriers and the MISSE avionics upgrade, which is the primary subject of this presentation. This upgrade is designed to address the operational and other startup issues we've experienced over the first 2 years of on-orbit ops. It improves reliability and resiliency, expands communication speed and options both within the on-orbit facility and with the ground. It increases data experiment interfaces and power options for our customers' convenience, and it simplifies data collection and reporting to help us speed up our data deliveries. I won't read this whole chart, but the key takeaway is that we've added significant redundancies throughout the MISSE system to enhance reliability, resilience, and capacity, while also simplifying our ground ops and our ability to collect and report on-orbit data. Just to point out a couple of significant operational enhancements. We will be able to update active experiment scripts via Wi-Fi from the ground and support multiple active experiments on a single carrier with 2 isolated power supplies per carrier. Our redundant independent comm paths and a fault-tolerant mesh network architecture add significant levels of system resilience and redundancy. And the updated ground software and enhanced status event reporting will improve our visibility into on-orbit conditions. I'll go into more detail on several of these enhancements and how we created them in the main presentation. Now we're excited about the new capabilities that we're about to launch in MISSE 14. The upgraded avionics meet the objectives we set for ourselves over a year ago, and we believe that they will significantly improve our on-orbit and ground ops, and our ability to get our customers what they want and need, while growing our ability to accommodate a wider variety of experiment designs and expand commercial space testing as a service. MISSE is primed for expanded utilization for testing of virtually any type of customer technology. Thank you for listening to the summary of the MISSE Avionics Upgrade presentation. Please contact.
Hello, today we'll talk about design and development of structural health monitoring experiments on International Space Station. My name is Andrei Zagrai and I'm PI for this project, and my co-author is John Santosh, who just graduated with master's degree. Among key needs in space system development is continuous improvement of safety and reduction of operation cost. Structural health monitoring is seen as one of key technologies that could allow to address those needs. These slides illustrate some approaches for structural health monitoring of space vehicles. The sensors may be installed on a structure of the space vehicle, such as, for example, piezoelectric sensors or magnetoelastic sensors, which are shown here on the slide. And these sensors enables a variety of structural health monitoring technologies, such as, for example, the guided wave structural health monitoring using acoustic transmission, which is shown here by using the elastic waves propagating through structure and looking at different signals of elastic wave, as well as electromechanical impedance method, which looks at the higher frequency vibration in the neighboring of the sensor. So this information from such methodologies are extracted using a specialized signal processing and feature extraction procedures, and then fed into some decision support algorithms such as statistical analysis or neural networks, so that at the end we arrive into sort of a traffic light decision where the red would indicate the structure is damaged and green would indicate the structure is okay, and the yellow would suggest that an operator would look at the structure to check with a different methodology to see if the structure would be actually damaged. To explore long-term effect of space environment on the components of structural health monitoring system and to demonstrate feasibility of SHM during long-term space missions, we need an active experiment on International Space Station. And by active experiment, I mean that in our payload there is active electronics which are powered, which will transmit elastic wave. The elastic wave will be received, will collect the data and store the data, which would allow us to infer how space environment affects the structural health monitor. Let's discuss the main active experiment in the payload. It is an experiment in which elastic waves are sent by a piezoelectric actuator, which is labeled as A here on the slide, and the waves will propagate through the payload plate. This is a plate number 1. They will reflect from the boundaries. They will also go through a direct transmission from A to D, and in this path we will collect the signals, which are shown, examples of the signals on the bottom of the slide, at different frequencies from 25 kilohertz all the way to 450 kilohertz. In such a way, we are able to collect the dispersion curves, which are curves which shows how group velocity changes with frequency. And those dispersion curves are essential for understanding the wave propagation in structures under space condition, and to our knowledge has not been collected yet. These curves are also very essential for structural health monitoring because the transmission of the sensors and reception of the sensors will be governed by those dependencies. In addition to collecting the dispersion curves, we also have here two additional experiments which are enabled by the same actuator, looking at the condition of the detection for the notch and also on the condition of the bolted joint. The payload was launched on the 2nd November 2019 as a part of the NG-12 ISS resupply mission. It was a great experience for the student team to attend the launch, and the payload is currently on ISS. It's been turned on, and then it was turned off because of the need for relocation to a different position. Nevertheless, we believe that we have collected some data which would be very useful for our studies, and we also have a couple of passive experiments in the payload. So we expect the return of the payload and analyzing the data when it's come back.
Hi, my name's Matt Francis. I'm President and CEO of Ozark Integrated Circuits. And what I'm going to present on today is a summary of our experiences over the course of about a year and a half, going from developing a sensor internally and then getting that device space qualified for low Earth orbit. And what you'll see is we developed a really unique qualification platform that operates within the MISSE platform, as well as a back-end solution for taking that data, understanding it, and really starting to gain some insight. And so the specific example you're going to see is a UV data acquisition system that we developed for the MISSE platform. What Ozark IC does is bring the Internet of Things to everywhere it isn't. Our core technology is what we call an Xnode. It's a single board computer that can do data acquisition in an extreme environment. It's designed to operate anywhere that normal electronics won't, so at very high temperatures, low temperatures, or an extreme vibration. They can also be augmented to do remote control depending on your application. The way we do this is we have unique IC and package co-design capability. We use additive technology for quick turn integration. We also use some pretty exotic semiconductors to get the job done. So this is the problem we were trying to solve. We have a unique silicon carbide based sensor that we had developed that is about 30,000 times more sensitive than any other sensor in this range. And what we wanted to see was how that sensor would operate in low Earth orbit and also get it space qualified. And so we needed to develop the hardware to do the readout in orbit, integrate that into the chassis, get it put on orbit, and then finally start to take data from it. And so as you'll see in the talk, we worked with Alpha Space in Houston on all those integration steps and with great success. This is what we developed. We call it the Xnode Uv100. It's a DC curve tracer designed to work in space. It has a 32-bit ARM processor and 4 channels. And so we built 3 of these modules and deployed them to the space station. And we based this loosely off of previous work done by the NASA Glenn Research Center. If you go to the full talk, I'll go into the details of how we integrated the board and various versions of the dashboard that we developed. But this is ultimately what we came up with. We're using a state-of-the-art dashboarding tool called Grafana, along with a lot of back-end scripts and programs that handle all the data sets and get the stream from the space station. But now you can see that we can go from, on the left, we're seeing real-time UV data, we're seeing our independent sweeps in the middle, and we're also correlating that with live video from the space station, as well as the ISS location. So thank you for taking a minute to listen to the executive summary of this work that was supported in part by CASIS and MISSE. We would love to talk with you. If you have any questions about our Xnode technology or how we could apply it for other space qualified parts, please feel free to reach out to me at francis@ozarkic.com. And of course, I encourage you to listen to the complete talk and learn a lot more of the details of how we built our data science platform and integrated it with the space station.
Corrosion is a major concern of building components and infrastructure at military and civil works facilities. Historically, for NASA, steel launch towers and related ground support equipment were scheduled for sandblasting every few years to assess whether or not corrosion was forming on the paint. This has been an expensive process due both to the labor involved in assessing the degree of corrosions, as well as the downtime incurred while sandblasting and repainting structures. In this presentation, we report IMEC's progress on continuous wave terahertz emitter detector research and the terahertz imaging application for under-insulation corrosion detection. The internal active thermal control system aboard the International Space Station operates using a water-based coolant and is prone to corrosion. Leaks caused by corrosion may disable part of the apparatus and cause catastrophic damage. It is important to detect corrosion at early stage. However, it is not an easy task for visual inspection, partly due to the covering of insulation jacket. Terahertz radiation can penetrate and inspect non-conductive material for defects and is refracted from metallic materials. NASA has used the terahertz for space shuttle tire inspection and aluminum corrosion detection. The drawback of such system is that it is a power system that is bulky and expensive. Terahertz imaging is performed with slow scanning using a single emitter detector pair. A CW terahertz system can be more compact and cost less, but still requires mechanical scanning for imaging. IMEC's solution is to use photonic integration on chip for reduced cost and high performance. The emitter array generates narrow, high-intensity steerable beams, while the detector array allows for a fast, coherent detection of terahertz signals. The terahertz emitter and the detector features IMEC's state-of-the-art terahertz photomixer that uses the silicon germanium photodiodes and can be directly integrated with active components. It successfully leads to a truly portable terahertz imager with high performance. IMEC's terahertz emitter has achieved up to 4 times higher terahertz conversion efficiency than that of commercial emitters. We have also demonstrated array fabrications and verified for using IMEC's single-element terahertz emitter and detector. We demonstrate terahertz contrast imaging with a felt oil placed in an envelope. Using multiple terahertz frequencies to form false color images, it shows layer thickness variations clearly and provides more structural information than X-ray. A terahertz imaging setup using a 2D scanner and IMEC terahertz emitter and detector pair has been used for live demonstration at several conferences in the US as well as in Europe. We demonstrated terahertz beam forming by comparing the beam profiles of a single antenna-coupled germanium photodiode and a small 1x4 antenna-coupled germanium photodiode array. As can be seen, the directivity is already improved even with such a small. To explore terahertz imaging applications, we performed corrosion detection experiment on aluminum, steel, and brass using commercial terahertz system. We demonstrated the capability of terahertz imaging through paint or insulation materials. Early detection of corrosion on ISS will help to maintain the safety of crews and equipment. IMEC is developing an innovative terahertz corrosion detection imager. Experimental results have demonstrated feasibility of detecting corrosion on the paint or insulation.
All right, some really detailed stuff there. Well, go into the bottom of your screen and look at the Q&A button there. Click on the Q&A button and put in your questions. There's absolutely got to be some questions in this really detailed material. So now what I'll be doing in just a moment as we get everybody else up, we'll be bringing the session chair in. And he'll introduce his panel, and then we will go in and have a special question coming off from the audience. And we've got all the panel, now all you need is Willie. Okay. All right. Willie, turn on your video and your audio, please. Turn on your video and audio. There we go. All right. Willie, go ahead and introduce your panel, and then come back to me, and I'll ask the first question.
All right. Thanks, sir. To some, good afternoon. To others, good evening and good morning. Welcome again to the Technology Development Demonstration session of the 2020 ISS Conference. As mentioned, my name is Willie Williams, and I am the session chair and a member of the ISS program. There are 6 presentations that we noticed that are part of this session, and I will introduce the presenters in the order of their presentations. Santosh Vijapur, a principal scientist from Faraday Technology, Inc., will be doing the next generation water recovery and sustainability closed loop living. Florence Gold, NASA Hunch, implementation project manager at NASA Hunch, will be doing a NASA presentation with high school students and making a difference in today's and tomorrow's STEM. Mark Shumbera, Director of Business Development at Alpha Space, will be doing the upgrading of MISSE, enhancing reliability and experiment support. Andrei Zagrai, Professor at New Mexico Institute of Mining and Technology, will be doing the design and development of structured health monitoring experiment in International Space Station. President and CEO Mark Ferris of Ozark Integrated Circuits, Inc., will be doing a year in ISS real-time UV data acquisition on the MISSE platform. Last but not least, Zhang of imec-USA will be doing under installation corrosion detection using transhertz waves.
All right, Willie, thank you for all those introductions. And now I'd like to ask Blaine Ederlison to turn on his camera and his audio, please.
Yes, is it on?
There you are, Blaine. Blaine, go ahead and ask your question of the panel, please.
Hello, can you hear me? Wait, what?
We hear you, go ahead.
Okay. My question is for Dr. Gold. Are there any plans to have college internships based around NASA Hunch?
So thank you, Blaine. I know you were a past Hunch student and now in college, so that's an important question for you. And hopefully for many more past Hunch students. And definitely we need everyone who has an interest in NASA and space exploration to help in future space explorations. And we'd love to keep our Hunch students involved even through college. The main important part would be for mentors. So I know you're in New Jersey. We have schools actually closer to where you are going to college now in New Jersey, or even your home school that you went to. If you could be involved in helping schools that you have been to or in your area, that would be great. And that goes for all our past Hunch students and any high school student, but the ones who have been in Hunch, that really helps because they already know the procedures. And I know you've spent several years in our program. So thank you for that question. And thank you. I hope to stay involved. Keep emailing me.
Okay. Yep.
Okay.
All right, thank you, Florence, and thank you for that question. Willie, go ahead and take it and run the panel through your questions, please.
The remaining four questions that we have here for Flow Goal, how can employees at different space companies get involved in Hunch?
So that's a great question, especially for right now when we have these different companies involved. And I don't know, is Glenn Johnson, can you bring Glenn Johnson on? I think he's on our participants at least.
No, we
but,
can't bring anybody else in, I'm sorry.
Okay, but he does our design and prototyping projects. So in actuality, we were initially funded by the ISS. We work for Johnson Space Center International Space Program Office. And our projects were very focused on the ISS. But now we have moved beyond, and we actually have other companies, space companies that are involved in our program. And so they actually have given Glenn Johnson, he's the design and prototyping person, projects that they want to see developed. So we're not just doing the ISS projects anymore. And also with our manufacturing, we're not just doing the ISS. We were big into single stowage lockers, but now we are building some lockers for other companies also. So we have expanded it to other companies. Our first love, of course, is always the ISS program office there, but it has expanded to other businesses. So thank you for that question.
Okay. All right, next question to Alpha Space. Were there any blind spots on ISS, and if so, how did you fix it?
Great question. Thank you for that. I'm not sure that there were blind spots necessarily, because we all know that designing hardware and having it operate for a long term in space is a difficult thing to do. I think more or less what it was is that when we first designed the system, the MISSE system, we weren't completely understanding what customers would want in the system. And we guessed, of course, and we guessed well because it's been highly utilized. But then there are still some experiments that needed other types of interfaces, other types of services that we really couldn't provide very well. So I think that is one thing that really kind of was the impetus for us to upgrade the avionics system to create better interfaces for customers. And then another one is resilience. I mean, of course, we had some failures on orbit, but we've overcome the vast majority of them, you know, just on the ground by operations. But we want to minimize that, right? So we don't want to have any type of glitches or any type of pauses in the experiments. So that's another reason why we have a lot more redundancy in the system with this one. And of course, new COTS parts come available all the time, new parts, and they're better, right? So they have better performance. So I think all in one, that's kind of the impetus for the upgrade.
Okay, great, thank you. All right, the next question is from Lane Kennedy to Flo. The message is, thanks again for all you are doing with Hunch. Amazing work. Among all the many projects, is there a particular project or outcome that you are most inspired by?
Yes, there is. And it's a project this year, and we're working with NanoRacks to bring this project alive. And it's called an Ag Lab. So it's going to go into NanoRacks, has these little 4 by 4 by 6 inch square rectangular prisms. And we are working to put a plant growth chamber. So we were working, Hunch students are working, NanoRacks came to us. That's a company that wanted our help. They came to us and said, well, can you make a generic one so that students all over the world, not just in America, NanoRacks can go international, all over the world could, if they have a plant experiment they want to do, they can put that plant experiment in that little Ag Lab and send it to the space station. So I'm really excited about that project, which Hunch has already sent several plant growth chambers to the ISS.
Okay, thank you. Okay, another question from Claudia Lindener to Hunch. All the other education projects in this conference require funding or payment, but Hunch generates high quality products actually used on the ISS like regular materials. If I understand correctly, according to their understanding, do the students produce the material for the ISS, or the other businesses you just mentioned get paid for them?
So that's a great question, and it's the answer is that we purchase the material because we have students now making flight hardware for us. So we have to purchase the material for them because it has to have certain certifications, and we have to have the history from the day that material was made to the day it goes to the ISS. So it involves a lot of documentation. We purchase the materials. We also purchase the tooling. And in the end, it's a win-win situation because NASA wins, because we don't charge NASA for making these single stowage lockers for us. And the students win because they are actually getting the experience to make flight hardware, and we don't give them any breaks. They're just like if it was Boeing or Lockheed making that hardware for us, they have to do precision machining and documentation and finishing and everything like that. So we don't charge for any of that, but in the end, it does use up teachers' time. And so I have several schools that just have Hunch classes, and the teacher's a math teacher. Well, we don't charge the school anything, but it is one more class that would have had her as a math teacher, and instead she's doing NASA Hunch, if that makes sense.
Yeah, so funding for the Hunch project comes from where?
From the ISS program office.
Okay, great. And then the materials that are developed as part of that, they're provided to free of charge and are sold to others?
So the schools get that material free of charge. We say it cost us about 1/10 of the price to make a single stowage locker than it would if NASA went out and asked a Lockheed or Boeing or other industry to do it. So we save them a lot of money, and they fund us.
And provide an excellent space-worthy product. Thank you so much.
Yep, thank you.
Okay, we have a history question for Mark. And for Mark, the question is, was MISSE always owned by Alpha Space?
No, actually. There have been so far 13 MISSE missions. The first 8 were NASA missions, and they were progressively more complex as they went along. And then Alpha Space commercialized the MISSE platform in 2015. And it was upgraded. It's much different than the original 8 MISSE platforms that were on station. And so the upgraded, much more flexible platform was then launched in April of 2018. And we've been operating on station since as a commercial entity since 2018.
So DOD had their foot in that for a little while, right?
Oh, they did, yeah. So the DOD did fly quite a bit of materials and other types of samples and whatnot on previous MISSE missions, and they still do. So they're still a customer.
Great, thanks. From Mark Gilterman, we have a question. Does Ozark plan to expand Xnode to test other electronic components?
Sure. Yeah, this is Matt Francis from Ozark IC. Yes, we're very interested in expanding. What we have right now is a very good for DC characterization. So like transistors, resistors, capacitors, and those kind of devices, 2-terminal, 4-terminal devices. And we're currently evaluating and learning about the new avionics upgrades to see how we can make use of those that Alpha Space is working on to do some new Xnodes that would let us expand into things like processors and power conversion circuits and other things that would be, like, for example, relevant to building satellite hardware. So And really, one of the aspects we're really trying to push on is the density of how many devices we can test, because we know that would help, obviously, as many customers as possible get that hardware flight qualified.
Okay, thank you. There's a question for Pritish Tiwara, and it's for Florence Gold. And the question is kind of a little bit off the topic of what your presentation was about, but it's related to it. And the question is, what are the opportunities for international students? This particular students had a lot of project ideas which they knew about in high school, but they couldn't apply because it was always for U.S. nationals only. And currently, they have an final year students, and they still don't know how they could participate and what opportunities are available for international students. So how would international students get involved with something like Hunch or similar to Hunch?
So actually, she's very right. Hunch concentrates on the United States schools. And we have 44 states involved, which is great. But we do have a few international that are participating in what we call the video challenge. Mm-hmm. And the video challenge makes inspirational videos for to promote NASA and exploration. So they're educational and they're inspirational. And we involve middle school. Actually, this year in the video challenge, we have elementary through college. So that's something that you get your foot into the Hunch program that way. And international students and college students are more than welcome to participate in that right now. Otherwise, those other products, we really do just stick in the United States, though we are thinking, and it's good you asked that question because that will actually push us a little bit more to including other countries in our work. So thank you for that question.
Okay, can that be found on your regular Hunch website? Is that a particular space they can go and locate that?
Yep, you go to www.nasahunch.com and click on, there's the 6 projects that we do, and just click on the video challenge and it will take you to the information about this year's video challenge, which is advancing space exploration through manufacturing. So I don't know what your ideas were about, but if they were about something, and manufacturing doesn't just include hardware, it includes soft goods, it includes culinary, it includes pharmaceuticals. It's, just go and check that out. We would love for you to participate.
Thank you, Flo.
Just want to add from university perspective, there is no restrictions on international students to participate in NASA projects. With some caveats there in NASA documents which list specific countries. Other than that, any undergraduate or graduate students, international, may be a part of the research project with NASA and ISS specifically, to my knowledge.
Okay, thank you for that input. Next, we have a question from Lima Kennedy. And the question is to all the panelists with experience on ISS. And the question is, I am most interested in the education side of things and to bring as much data and content from ISS to students, even in and close to real time, for instance, via public APIs. Can any of you share your thoughts about the education outreach opportunities that might be applicable to your work? To others on the panel?
Actually, I will address that from the Alpha Space and the MISSE perspective. We actually do host and have had educational experiments on the MISSE platform. So they've been sponsored, and we usually have a really good rate for the educational type STEM outreach programs. And yeah, Liam, I saw your presentation on the previous session. Fascinating, excellent job, excellent work. And you know, we would like to see if there would be some kind of way that we could potentially work together like that, because it's you know, it's a great program, and we have, of course, a platform that would be just suitable for, you know, real-time data coming down from orbit. So yeah, it's possible in MISSE, and it has been done.
Okay, thank you. Any others?
So I don't want to talk about Hunch, but I was the STEM education chair for this conference, and I was really impressed with some of those things. One that comes to mind, you can Google it, is Orion's Quest. They took so much data and information from the space station and brought it to the students and helped the actual researchers doing information on the space station. So look up Orion's Quest if that would be something that you might be interested in. Thank you.
Okay. Any more?
Yeah, I would just add, you know, as part of what we did, you could in our talk we used a lot of open source, for example, for doing the, you know, taking the data and applying it. And one of the things you learn along the way, that there are quite a few open APIs available for tracking where the space station is at and so forth. And so for any of those like myself that you know, volunteer for robotics clubs and things, there's some great opportunities to do some real simple things that really can make the kids understand what's going, you know, where what it means to be on the space station and what the data coming from orbit looks like. So, and if you ever, you know, wanted to do that or needed examples, feel free to contact me, because as I said, we've done quite a bit of that with high school students as well.
Okay. We ready to move on to the next question? Okay, from Vijapur, a 30 by 30 by 24 seems huge. Is that the WX systems that large?
So yeah, that is a very conservative estimate based on a linear scale up. We do not believe that would be the actual number when we scale up the system. You know, in electrochemistry, the reactors, you can do a stackable geometry wherein you can reduce the footprint. So moving forward, we do not believe, again, we do not believe that would be the actual final scaled up system.
Okay. And a question to Zagrai again. Your system sounds like a version of modal testing. Is it based on such a model?
Not really. You could potentially use the sensors as model sensors, but we primarily use it through the wave propagation. So it's essentially an ultrasonic system, like an ultrasound. You would go and take an imaging of defects. So it's based on the wave propagation rather than standing waves. However, we do have in the payload an experiment where we actually look at the vibrations of those plates before and after they're going to arrive. So it's kind of on the passive mode, not on the active mode, but we also take care of that element as well.
Okay, great. And a message from Ardina Provenzano. Are there any educational outreach or lesson plan material associated with MISSE?
Actually, no, we don't have any right now, but certainly something to consider producing. So yeah, great idea. Thank you.
Right. Another question from Andrina Provenzano. Any art projects connected with MISSE? I've always appreciated the artistic appearance of the platform.
Thank you very much. We like, it's very photogenic. We love the way it looks on orbit as well. Not to my knowledge, I don't know of any, but please contact me. Would be interested to hear your ideas.
Okay, great. And from Glenn Johnson, are there any Hunch students who are working for NASA now?
Yes, we have several of our interns working for us, and then we have hired full-time several of our Hunch graduates. One girl, she was in our fashion and design class, high school class. She went to college, became a fashion designer. Now she works for us on the soft goods program, making cargo transfer bags and other, there's a lot of soft goods projects that are needed for this, for the space station. One of my real interesting person that I have met is now a flight controller. And so we've been doing this since 2003. And we have Hunch kids kind of scattered throughout Johnson Space Center in particular, because that's our headquarters. But I'm hoping that we'll have more and more NASA workers throughout the facilities, the different facilities at NASA.
Great, thank you. I just have a couple here. We're at 3:25. We got 5 minutes, so I'll just take a quick minute here to kind of approach this one. Like, and for Vijapur, what is one of the issues that presently exists that your system will possibly help to improve or mitigate with the ecoless water recovery? Okay.
Sorry, yeah. Can you say that
Got the
again,
mic
please?
on?
Yeah.
You got the question is, what is the issue that presently exists with the ecoless water recovery that your system would possibly help to improve or mitigate? With the ammonia presence?
So currently, as water is passed from urine into the system, it goes into a distillation column where the water is evaporated and then large amounts of precipitate and things are formed, and that's a large percentage of that urea in the precipitate. To clean those distillation columns on the space station, they currently send up chemicals like phosphoric acid and chromic acid to dissolve that so they can waste those materials. The hope is with this type of approach, you'll be able to bioelectrochemically mitigate some of that post-cleaning and make it a simpler, less ground-dependent, continuous operating process to recover water.
Okay, thank you. And I don't know if it's a question or a statement. Santosh, the ammonia that is separated from urine, what is the use of that other than using it as a coolant for solar panels?
So, I mean, the byproduct nitrogen can be used as a fertilizer to prepare fertilizer for growing plants in the space station or, on other planetary surfaces in future. And hydrogen can be used to generate, I mean, that's a good generate power basically. So there are added advantages to the technology as well.
Okay, great. And we're at 3:28. I have one question for MISSE, for Sambro. What is the footprint available on the MISSE for experiments? What sizes are available?
Great question. And so we have standardized carriers, and we call them MISSE science carriers. And there are at any given time 12 of these carriers on the MISSE platform on orbit. And each carrier has two sides, and each side is kind of like a small box, and the box is 13 inches by 7 inches by 3 inches deep. Okay. So those 13 by 7 by 3 inches deep, 2 per carrier, and then 12 carriers on orbit at any given time.
Awesome, thank you. Any other questions that we have that I've missed? I don't see any more on the list. We're at 3:29.
And Willie, you guys have done great. This has really been interesting. Things warmed up as you went on. And I really appreciate the work of you and your panel. Thank you, Willie, and thank you all your panelists for coming forward. A few of you look familiar to me. Maybe we saw each other once or twice in the past. So,
it's
all right. So, we're almost to the end. A little tiny bit left to go. We want to thank everybody who came and participated, all of our folks who came in and listened and watched. We had 120 something people in a technical session, maybe a few more than that. on the first day, and we kept fairly high numbers, and I'm really surprised and happy for the results that we had with the people that were attending. So I'd like to thank our sponsors, our platinum sponsor, Boeing, Jacobs, KBR, Leidos, Oceaneering, Teledyne Brown, and the Engineering and Innovation Technology Development Organization of the University of Alabama at Birmingham. We'd also like to be sure to invite you to attend the third and final day of the plenary sessions on Thursday, October 22nd. There will be some great topics there that will be discussed that day, so don't miss it out. Find out more about registering and about the schedule for that at issconference.org. Now I'd like to ask the rest of my AAS team to come up on screen. We got Jim. Patrick's coming. Oh, he's a test pattern. He is a test sometimes.
That's how he likes to be portrayed. He might be having a camera issue.
Patrick's having a camera issue. All right, so there he comes. All right, you got to see him again. So Thursday we started at 9, went to 2:45. Wednesday we started at 7 in the morning and went to 9:45 at night. And Thursday we went from, that's today, we went from 9 to 3:30. That's 27 hours of webinar, 113 presentations, 127 speakers, and a tremendous number of questions. I thank all of you all who made that happen. I thank the people who attended and sent in briefings and made briefings. Thank everybody who put in abstracts. We had 340 something abstracts to pick from to get to the, what was it, 113 that we actually presented. So that's a great effort there. Thank you to the AAS team for making it happen. And y'all go off, have a good afternoon, have a good Friday, and a good weekend to everybody. Thank you very much. This is AAS signing off.